Okay, guys. Today we're going to cover pages 21 through 23, which covers sum and difference formulas with trig identities. So these are the three formulas that are going to be worked on through this book. You can find them on your formula chart. Now, just a couple of notes. These two Greek symbols that you see are alpha and beta. Okay. They represent A and B, so you may hear me use A and B and alpha beta interchangeably. They just represent two different angles. And the other thing I want to point out is watch your signs on these formulas. Cosine actually has these backwards, okay? So when you see A plus B here, that's actually minus on the other side. So I'm just going to make a note. This is backwards in terms of signs, okay? The other ones are pretty straightforward. So tangent, you can see, has opposite signs on top and bottom. So the first sign, the one on top, is the same as your problem, and the second one is the opposite. Okay, let's dive right in. And our first problem says, can we find the exact value of 75 degrees, the cosine of that? And exact value is usually meant, let's go to the unit circle, but I've got a problem here. 75 degrees was never on my unit circle. So what can we do? If we look at the hint actually tells us we should rewrite 75 degrees as the sum or difference of two angles. And the easiest one that popped into my head when I saw this was 75 degrees is just 30 degrees plus 45 degrees. And those are both angles on the unit circle. And now you can see that this actually matches up perfectly with my sum and difference of cosines formula, which I wrote off to the side. If we just match these up, alpha is going to be 30 degrees, and my beta value is going to be 45 degrees. So let's just plug it in and set up the formula. And you guys can see all I've done is taken the alpha and beta numbers and plug them in. And now we can find all of this information from the unit circle. So for example, cosine of 30 degrees is going to be root 3 over 2. Cosine 45 is square root 2 over 2, minus sine of 30 is 1/2, and sine of 45 is root 2 over 2. Let's keep going through this and simplifying this down. Let's multiply these together. Root 3 times root 2 is going to be square root of 6 over 2 times 2 is 4, minus on the right-hand side, square root 2 on top and 4 on bottom. And we can put this together finally as just a single fraction. Square root 6 minus square root 2 over 4. And that is going to be my final exact value for cosine of 75 degrees. Okay? And the reason we picked 30 and 45 again is because they are on the unit circle. Okay, let's keep going. We're going to look at number 2 now. And number 2, the first thing that they mention is we want to find the exact value of sine of pi over 12. And pi over 12 doesn't have a memory value, which means it's basically not from the unit circle. So how can I make this something I can find an exact value for, or a memory value for? And we can basically say, well, pi over 12 is actually pi over 3 minus pi over 4. And these two are on the unit circle. So with this information, let's go ahead and rewrite our problem using pi over 3 and pi over 4. So sine of pi over 12 is equal to sine of pi over 3 minus pi over 4. And you guessed it, look, there's a difference. I can use my sum and difference formula. And so you can see I rewrote the formula for you. Now notice, this time the signs are the same. So since this sign is minus, we're going to follow minus and the bottom sign throughout this whole thing. Okay, and so let's go ahead and just plug these in. We've got sine of pi over 3 cosine pi over 4 minus cosine pi over 3 and sine pi over 4. Now, why don't you go ahead and take a second and pull these values from the unit circle, and let's see how it simplifies out. And you can see I went ahead and pulled these numbers. These are from the unit circle. All right, and let's go ahead and simplify this down further. So these are going to become square root 6 over 4 minus square root 2 over 4. And finally, I've got root 6 minus root 2 over 4. Interesting. Hey, look, My answer is actually the same one I got earlier from that cosine problem too. Okay, so let's take a look at the next problem. Number 3 says find the exact value of sine 42 cosine 12 degrees minus cosine 42 sine 12. And basically we're working backwards this time, and we just need to see which formula this looks like. So look at the pattern of the sines and cosines and what sign is in the middle of there, and let's see what formula this looks like. So I'm hoping that if you looked at your formula chart, you'd say, hey, this looks kind of like it would be a sine A minus B situation. You can see because of the minus signs that are in the middle that this is what we're going to match up. You can see that sine cosine pattern, sine cosine minus sine cosine. All right, so according to this, my A value, my alpha, is going to be 42 degrees, and my B value is going to be 12 degrees. And this is going to be sine of alpha minus beta, which is sine 42 minus 12. These are both degrees. And I get that this is sine of 30 degrees. Anyone remember what that is? That's just going to end up being 1/2, and that is my exact answer. Remember, all of our exact answers are just pulled from the unit circle, okay? So we can always find our angles on the unit circle and pull those sine and cosine values. Okay, so now let's kind of combine what we learned about arc functions with these new formulas we've got. And our expression says cosine of arc tangent of 1 plus arc cosine of x. Okay, so I've rewritten this with a little bit different notation with that inverse notation. It's a little easier to read. Now let's mix in that sum and difference formula. We can say that, hey, this is a sum of cosines. There's a plus in the middle, and tangent is in that alpha spot, and cosine is going to be in the beta spot. Why don't you take a second and try to plug all the numbers into the formula? I'm going to go ahead and do the same thing as well. Okay, and if we filled in our formula, remember you can find that on the chart, you should get something that looks like this. Cosine tangent inverse of 1, cosine cosine inverse of x, minus sine tangent inverse 1, sine cosine inverse of x. Now that's a mouthful, but not all of this is going to be difficult. Some of it's pretty simple to deal with. Tangent inverse of 1, wait a minute. I know that on the unit circle the tangent is 1 at pi over 4, and I can figure out the cosine of that. That shouldn't be too bad. And this one's really nice, actually. Cosine and cosine inverse will cancel out and just leave me with that plain old x. Minus, same thing, we know that the sine of this tangent inverse is going to be a sine of pi over 4, and we can go find that on the circle. Only this last bit is kind of messy, that cosine inverse inside of the sine. You may remember from arc functions that we're actually going to set up a triangle for this and have to solve it out in order to figure this out. And so if we set up our triangle here, we know that our value is going to be 1 and the flat side is our x for cosine. And we're going to solve for this missing side, and we should come up with square root of 1 minus x squared. Okay, so again, we would set this up and we would use Pythagorean theorem to solve it. Refer back to your arc function notes on page 72 and 73 for this, if you've forgotten. Okay, that's from the old packet. Now, what that means is the sine of this is going to equal the y side over the r side, and we're going to have root 1 minus x squared over 1. Okay, and so now we can go ahead and simplify this down even further, and cosine of pi over 4 from the unit circle, root 2 over 2. I've got that x with it, minus root 2 over 2, that's my sine of pi over 4, and finally bringing down that last piece, square root 1 minus x squared over 1. Let's keep simplifying this further. Square root 2 with an x minus root 2 times square root 1 minus x squared over 2. And now we could kind of put this together all as a single fraction, and we'll have x square root 2 minus, we can distribute this too if we want, but we can also just leave it as a second root, square root 1 minus x squared over 2. And that's my final expression for this problem. Okay, let's apply that same function again. Using the sum and difference formulas, we've got proving that the cofunction identity exists. Cosine pi over 2 minus x equals sine x. Now, we can already tell this is going to be a cosine a minus b, and my alpha looks to be pi over 2, and my beta is going to be x. Let's just go ahead and set up the formula and plug it in. Once again, guys, remember cosine has the backwards sign in the formula. And you can see now I've plugged in the pi over 2's and the x's for those spots. Let's kind of see how this simplifies out. Once again, we're going to use the unit circle, and let's go find the cosine of pi over 2, which is 0. Cosine x can't really be simplified, plus sine of pi over 2 is just 1 times sine x. And now, hey, this first section, because of this times 0, is just going to cancel out, has no value. And finally, I'm just left with sine x. And what we proved is that this is equal to cosine pi over 2 minus x. And this was actually the cofunction identity from the chart. So not too crazy, guys. As long as you identify what alpha and beta are, you can easily plug the numbers into the formula. Just watch out for those signs and make sure that you don't mix one of them up. Okay, here we've got a simplifying, and this time we're seeing a new formula. We're using the tangent formula. So go ahead and find that on your chart. And you should find the same formula that I've written in green. Go ahead and try to identify what A and B are. So if you did it correctly, you should get that theta is A and 3 pi is B. Now, let's note this is a plus sign, so I'm going to use the plus from these two and the opposite, the top one, here, okay? So we always use the same side, so top sign for this formula. Let's go ahead and plug these in and see what we get. And if we plugged everything in the right place, we should get tangent theta plus tangent 3 pi over 1 minus tangent theta times tangent 3 pi. Let's go ahead and try to simplify this down. So the value I know I'm looking for is going to be tangent 3 pi, and I'm going to go find that on the unit circle. And tangent 3 pi is going to be equal to 0 because of the unit circle, all right? And we can plug in the 0 for those locations. So we'll have tangent theta plus 0 over 1 minus tangent theta times 0. Now, we can keep simplifying this down. I can see that tangent theta times 0, that bottom piece, is going to go away. And tangent theta plus 0 doesn't really matter either. So I'm just left with tangent theta over 1, which is just actually tangent theta. Cool. All right, one last example for you guys, and this time we've mixed in solving techniques along with the sum and difference formulas. You can see there are two different setups here. I've got sine x plus pi over 4 and sine x minus pi over 4. And this whole thing is actually equal to -1. So each of those individually is going to make a sum and difference formula setup. And you can see I went ahead and wrote out that formula for us. And we're just going to set up the first one together. So let's plug in x is going to be my alpha value, and pi over 4 is going to be my beta. So go ahead and set it up, and let's see what we get. So this first section, I went ahead and did in blue. That is sine x plus pi over 4. And the second section I'm going to do in green. You'll see sine x minus pi over 4. Go ahead and try to set it up on your own as well. And now that we've plugged everything in, we can start to simplify this down. And you should pretty quickly see, before I even jump to my unit circle, these two sections are positive and negative versions of each other, and we can just cancel those out. Now let's go ahead and jump to the unit circle and try to fill in whatever pieces we can find. Cosine of pi over 4 is root 2 over 2, and I've still got that sine x out here. And I've also got the same thing right here, sine x, and that cosine pi over 4 is another root 2 over 2. Let's keep trying to simplify this. So I see that there are two of these, so let's put 2 sine x times root 2 over 2. And conveniently enough, actually, this times 2 and this divided by 2 cancel out. And so currently I've got this, square root 2 times sine x. Okay, and I just put the square root in front for convenience sake right now. And all of that is supposed to actually be equal to this minus 1 that we were talking about earlier. And now I want to solve this. So we're going to use the same techniques we used with solving equations. I'm going to divide by square root 2. And so I've got sine x equals negative 1 over root 2. Well, this is kind of an ugly looking situation. Let's go ahead and simplify this down so that we can get a proper solving setup. We'll rationalize our solution with root 2 over 2. And we've got that sine x equals negative square root 2 over 2. And this we can find on the unit circle. So what angles will be my solution for this? I'm hoping that you find 5 pi over 4 and you find 7 pi over 4. And since this does have restriction to it, we only want solutions between 0 and 2 pi. These are going to be my actual full solutions. I don't have to include the plus 2 pi n on there.